Welcome again. It is PUE3122 Advanced Digital Signal Processing. We are in the second week. Again, Dr. A.R Zubair is my name. This is our fourth video. Today, based on the questions we are asking last week and on our WhatsApp platform, I realized that there is need to reintroduce you to basic signals. So let me digress a little bit from Z transform. Let me take you through some concepts on basic signals. First, there is what we call the unit step signal. It is written as U of N. What it means is that U of N equals 1 when N is greater or equal to 0. It is 0 when N is less than 0. Please take note of that. Another thing is that for that step function, there are certain things you should always remember in signal processing. There are certain operations that you must master how to do them. There is the scaling, there is the shifting, there is the reversal. There is also resampling. This 1, 2, 3, 4. You should know how to do them. Now, so as I go along, I'll be mentioning some of them, what they mean. First, if you are giving that, diagram, we can draw this diagram as 0, it will be 1, 1, 1, 1, 1, 2, 3. This is N. N is the independent variable. N is what? Independent variable. And it is related to time. This axis is the signal magnitude. Now, at -1 it will be 0, -2 it will be 0, -3 it will be 0. So we say dot, dot, dot. Here too we say dot, dot, dot. This dot, dot means that this trend of ones will continue. That means at 4 we're having 1, at 5 we're having 1, at n equals 1,000 we're having 1, at n equals 1 million we're having 1. The zeros will continue this way. At n equals -4 is going to be 0. That's the meaning of these dot dots. So this is the graph for U of N. This is the mathematical equation for U of N. Now let's introduce scaling. If I say give me a function which is 5UN, this is scaling. So this means it's going to be the same as UN but multiplied by 5. That means at 0, at 1, at 3, this will be 5, 5, 5, 5. That trend continues like that, 0, 1, 2, 3. -1, -2, -3, -4. This is just 5. Multiply the value, the magnitude. So we are not tampering with N. This is known as scaling. You affect the magnitude of the signal. If I give you y of n equals -3un, that means this will look like this. This is n. It will go down. This will be -3. This will still be 0, 0, 0. This is location position -1, -2, -3. This trend will continue. This is 0, 1, 2, 3, 4. This trend will also continue. The two of them are scaling. We scale to multiply by 5. Here we are multiplied by -3. Let me introduce reversal. Let me introduce shifting first. Let me introduce shifting. If we are talking of shifting, if you are giving u of n minus 4, we are talking of shifting now. Now the samples will be shifted. Whatever is inside this bracket, take it to be equal to 0. N minus 4 equals 0. Therefore, n equals 4. This does not mean that n is 4. What it means is that whatever is used to be at 0 before, shift it to 4. Like one of you told me last week, does it mean that n is 4 permanently? No. This is not saying that n is equal to 4. This is saying that the signal should shift 4 to the right from 0 to 4. Signal should shift from 0 to 4. Now, what does that mean? The guy at 0, this sample at 0 before will now be at 4. This will be 5, 6, 7, 8. So this will be 1, 1, 1, 1, 1, 1. That trend continues like that. You know that 0 has shifted to 4. -1 will shift to 3. -2 will shift to 2. -3 will shift to 1. 0 will be here now. This trend will continue like this. This is un of -4. If you can compare it with u of n, you will see a shifting. It's like this sample shifted to the right. N equals 4. Let me introduce another one. If I give you u of n plus 2, this means what? This means that n plus 2 equals 0. N equals -2. We are not saying that n equals -2. We are saying that whatever is used to be at 0 before should now shift to -2. So if I draw this one here now, what used to be 0 before will now be at -2. This will be -1, 0, 1, 2, 3. So I'm going to have 1, 1, 1, 1, 1, 1, 1, 1.